Hi, and thank you for joining us to this video about the testing of a line differential protection in the SIPROTEC DigialTwin. In this example, we have a process bus application with the analog values being received as sampled measured values. However, as we are doing our process bus implementation in SIPROTEC DigialTwin stepwise, and the subscription of the SMV in the client devices has not been released yet, we are going to inject the protection devices directly. From that perspective then, we are testing in the same way if we have line differential protection for conventional applications for process bus applications or for mixed applications. That is where one end uses process bus technology and the other end conventional implementation. And the first thing that we need to think about when we test a line differential protection is that we need to inject both ends of the line simultaneously. And the best way to do it is using the COM trade replay. So, we will use one file, including the injection for both ends. If you don't have a combined COM trade, for instance, if you got from the field independent files for each end, you can merge both files in one using our SIPROTEC software. I will show you how. Start SIPROTEC and open the first COM trade. Let's say in this case, the one from the left side. And then insert a new record selecting the file from the right end. In such a way, we have both COM trades in the same file right now, but if you look at here, we got some time differences. So, it is quite important that we synchronize the faux records. And for that, we go to Edit, Synchronize Fault Records. So now that the signals got aligned, we are ready to export the file. First click on File and then Export COM trade. The next step is putting this COM trade available in DigialTwin. For that you log on in the tool, click on Project, Test Files and select the icon with the plus symbol. Select the files, you will need the C, F, G and DAT files and upload them. So, once we have it here, then we go to assign the information that we have in the COM trade to the devices that we want to simulate. And for that, we go to the matrix routing. We select, for example, current, then we select as source our COM trade and as destination our protection devices. We do it one by one. We start with the device of the left side. Assign the phase 1, the phase 2, and the phase 3 from the corresponding signals from the COM trade. After that, we do the same for the device located at the right end of the line. So, we connect here also phase 1, phase 2, and phase 3. We do the same with the voltages. There is a summary table here where you get the routing overview. This view shows, for example, that the voltages of the COM trade LR51 have been assigned to device 5, and if you move your mouse closer, you will see the name of the device, in this case L51. Voltages have been also connected to device 8, which is the R51. Keep in mind that the routing shall be done when the simulation is stopped. Now the preparation is ready, and we can start our simulation. In this application, we are going to test the goose messages as well. We have the position of the circuit breakers and disconnectors being acquired by the merging units, and they are transmitted via goose to the devices. And we have also the trips being released by the protection device and transmitted to the merging units. So, we start with one static injection. Note that we can still do both static injection and COM trade replay, and we can test the different positions of the switching devices. For the static injection, we can also use some preset values. In our preset 87L values, circuit breaker and disconnectors are closed by forcing the corresponding binary inputs of the merging units. These values will be transmitted via a goose once we inject them, and the position will be shown in the graphic display of the protection devices. If we want to test a different position, we go to the merging unit, for example MUL51, and force the binary inputs related to the circuit breaker to the open position. The change takes also effect in the display of the protection device. In this way, we can test those goose messages corresponding to primary devices' positions in the DigialTwin. With the static test, it is also possible to run some initial test to prove the right scaling and configuration of the analog values. On the other side, the trip is released by the protection device, but the circuit breaker is connected to the merging unit. This means we need to send the trip command from the relay to the merging unit. For that, we also use goose messages. Here I have also prepared some LEDs in the merging units to show the external trip indication being received and the corresponding operation general originated in the merging unit. Now we are ready to start with the protection functionality test. As first, we want to test the line differential protection. Remember, we have already prepared the CALM trade file, so now we are going to replay it and analyze the response of the protection devices. We select the CALM trade and then we click on the play button. L51 has tripped by line differential protection due to a failure in phase B. In the MU-L51, the LEDs indicate that the trip has been received and processed by the merging unit. If we check the device located in the right side of the line, R51, we see that it has also tripped by phase B, and the MU-R51 has received and processed the trip as well. We clear the LEDs and displays on the devices and get prepared for the next injection. Now, we want to test the response of the distance protection. Therefore, we block the line differential protection. For that, the function key F4 in L51 has been prepared. We execute the blocking and prove that both devices are blocked. The LED 15 shows the indication 87L inactive. We proceed to inject the CALM trade again and check the results. Normally we want to analyze each test more in detail. With that in mind, we have included inside the SIPROTEC digital environment several applications that you can use to improve your testing experience. As example, you can get access to the web user interface of the devices to read the fault logs and get understanding of the events. It is also possible to download the fault records to be analyzed with the SIGRA online application. And if required, temporary changes can be done in the web interface and permanent changes in the DIGSI 5 application to have the final configuration ready for download. You can see in the SIPROTEC DigialTwin, you can test your settings, the algorithms, the Goose functionality, inject prepared CALM trades, analyze faults, correct configuration files and much more, everything in the cloud. Thank you very much for your attention and then see you next time.